Hi, this is Dave Johnson with another edition of Math Off Topics. So, first, I'd like to start by saying that my last video on the fundamental theorem of calculus and L'Hopital's rule applied to a limit had a serious error in it. And so I've taken down the video, and this video is a replacement of it. I'd like to acknowledge the helpful comments that two commenters made that showed me that, in fact, I was in error. And so I'd like to do the problem again and point out what the error was. And hopefully, you all will learn something from this, just as I did. And before I do that, let me add I'm just a human being. I do make mistakes. And I have a Master of Science in Applied Mathematics. And I do have a PhD in Cognitive and Neural Systems, which is neural networks, essentially. I did my dissertation in speech production modeling. And so there's a lot of math there, but there are some serious math people out there in the world and on the internet. And I'm honored that some of those people are looking at my videos and taking the time to make comments on them. So I do appreciate anytime anybody who wants to make a suggestion or has a criticism of anything in my videos. I'm very happy to hear it. And so, but I do want to do this problem correctly, I hope. And so let's get into it. So again, the problem is the same as what I started with last time. So limit as x goes to 3 of this integral, integral from 3 to 3 e to the 2t dt, divided by x squared minus x minus 6. And it doesn't take much to realize that this is going to be indeterminate, 0 divided by 0. The numerator is identically equal to 0 because of the limits. If the limits are the same here, then the integral, the definite integral, has to be 0. And the denominator is going to be 0 anytime x is 3 or negative 2. And so in the case where x approaches 3, you get the indeterminate form 0 divided by 0. The mistake I made in the previous video was to suggest that we could replace this 3 with an x because when you take the limit, it looks like, well, it's going to be the same, but it's not. Since this numerator is identically 0, there are two places where the function's undefined, this function, undefined at negative 2 and 3, but otherwise it's identically 0. And in fact, the limit as x approaches 3, whether it's from the right or the left, is going to be 0. And so really this limit is 0. Okay, so now this is a different problem. It has a very different behavior. It has a different limit. Okay, so let's look at this. Because the numerator is going to be 0 when x is 3, and the denominator is going to be 0 when x is 3, this is also indeterminate, so 0 divided by 0. And because of that, we can use L'Hopital, which means we have to differentiate the numerator and the denominator. Well, okay, so let's do that. So let me write limit as x approaches 3. And now we're going to say derivative with respect to x of the integral from 3 to x of e to the 2t dt, divided by, and then the derivative with respect to x of x squared minus x minus 6. And so I'm just applying L'Hopital's rule. When we do that, we still have limit as x approaches 3, but the derivative, if we're taking the derivative with respect to x, and we have an x in the upper limit, and we have a constant in the lower limit of the integral, the fundamental theorem of calculus says when that happens, we can take the integrand, evaluate it at the upper limit, and that becomes our result. So e to the 2x. So we get e to the 2x in the numerator. In the denominator, we can all differentiate that polynomial. So we get 2x minus 1. And when we evaluate that limit, it's no longer indeterminate. So we get 2 times 3 is 6. So we get e to the 6 divided by 6 minus 1, which is 5. And so that is the result. And notice these results are different. So this top problem, which was the first one, the problem that I was really addressing in the previous video, had a limit of 0, whereas this different problem has the limit e to the 6 divided by 5. I hope that's been helpful. I apologize for any confusion. I hope if this has been helpful, you will like and subscribe, and I will see you in the next video.